Hello, and welcome to the first of many webinars that the Foundry will be presenting over the coming months. These webinars will be looking at all of the products that the Foundry produces, but this week we're going to be focusing on Modo 10, and in particular Modo 10.1, which has just been released. So I want to start by introducing myself. My name is Andy Brown, and I've been a creative specialist at the Foundry for just over 3 years. And prior to that, I was a freelance 3D artist, and I was also involved with the Luxology team in the development of Modo going all the way back to version 101, which is about 10 years ago. So I feel like Modo is part of my DNA in some way. And in truth, Modo has been very good to me over the years. It's allowed me to meet and work with some amazing and very talented people, and also visit some incredible companies. So with that in mind, during this webinar, I wanted to talk to you all about one of the many reasons I enjoy using Modo so much. And more specifically, the single reason I got so excited about Modo in the first place. And that's the underlying principles behind tool construction and modification, or how I've described it here, Modo's modeling paradigm. So over the next hour or so, I'm going to be giving you a taste of what it's like to model in Modo. I'm going to lift the lid on how tools work by explaining Modo's tool pipeline and showing you how to develop and modify tools. And finally, I'm going to take a look at Modo 10.01's new procedural modeling implementation and how it relates to Modo's modeling system. So a few years ago, I visited a well-known car company, and whilst I was working with some of their designers, the chief designer came in, and after explaining to him what we were doing, he came out with a quote that's been burned into my brain ever since. He very aggressively said to me, "I don't care about process, only results." Now, he was the boss, so I understand why he said it. But as artists and designers, whenever we create something, we have to grapple with these two things. In order to create a result, we have to engage in a process. Now, in our world of 3D, software is the process, or at least a big part of that process. So when we make or model something, the process that we engage in could be described as either mechanical or exploratory. An example of a mechanical process is model kit construction. So you have a set of parts and some instructions, and if you follow the instructions, you'll get a result. An exploratory process is the kind of process a fine artist might go through. It's a process that encourages you to make mistakes, and through those mistakes, a result evolves. Now, both these processes are valid, both require skill, and both require an eye for detail. And there are most certainly different flavors of them, but the process you lean towards will depend on what you're modeling, what your motivations are for modeling it, but most importantly, I think it depends on your personality. Now, as software developers, we have to be acutely aware of this. The problem is that we're making one piece of software, but there are thousands of different artists who model different things and like to do things in different ways. So for a piece of creative modeling software to be successful, it needs to be flexible. And that's a very difficult thing to design well. Now, I think Modo does a great job of giving you that flexibility. It allows you to engage in what is an intrinsically technical process, but it does it in a way that allows you to explore possible avenues through that process. So let's take a look at this in more detail. Now, learning Modo isn't just about learning a set of tools and what their various functions do. That's certainly part of it. But if that's how you approach it, then you're only kind of scratching the surface. The key to learning Modo is to learn the rhythm of tool selection and construction. And once you're in that rhythm, it's a very dynamic modeling environment. So let me show you what I mean. I've got this model of a tractor. Now, once you've got something modeled, Modo's system really comes into its own when you start to modify an object. So let's run through some various editing steps. So if we go to this funnel on this tractor, and I'll make a selection, and I run a tool, like the move tool. So say I want to scale the size of that funnel. Well, at the moment, by default, the move tool is always aligned to the work plane, and the work plane is this grey grid that you see in the viewport. And as I rotate the object around in the viewport, you can see that work plane is dynamic and shifts depending on how I'm looking at the object. But that tool handle by default is always aligned to it. So in order for me to scale that funnel correctly, I need to modify the tool. And what we do in Modo is modify it on the fly using various action centers, fall-offs, or snapping behaviors. So if I go to this action center menu at the top, I can change the action center to selection, and the tool handle now aligns to the average normal of that selection. So I can then scale that funnel accurately. So let's do something else. So if I make another selection, there we go. So this next editing operation is I want to slide this selection along the top of the engine. Now, if we're on the move tool again, you can see that the tool handle is at a strange alignment, and that's because I've still got this selection action center active. So it's trying to average the normal of all of those selected polygons. So what I can do is change the action center. So if I go to this menu, let's change the action center to element. Now what element action center allows you to do is it allows you to define the position and orientation of a tool handle based on any element that you select in the viewport. So if I right click on this polygon, you can see the tool handle aligns to it, and then I can slide that selection perfectly across that plane. So I'm constantly adapting the tool. Let's do something else. So say I want to scale each of these notches on this wheel. So first of all, I need to make a selection. I'll just expand that. Okay, so I run the scale tool this time, and you can see the tool handle is nowhere near the selection, and that's because I'm still using the element action center, and it's where it was last time. So let's change the action center again. So if I change this now to local, the tool handle will jump, and now I can scale each of those disconnected selections locally. So there's an example of 3 completely different editing operations using basically a transform tool and then modifying that with a different action center. But there's other modifiers that we can use. So let's do something else. So if I select center of this wheel, and I'm going to align the work plane to it. So that work plane is adaptive. You can put it anywhere in the scene relative to a piece of geometry. And this time I'm going to add a fall off, which is another type of modifier. So let's drag that across that selection, run the move tool. Again, the tool handle aligns to it because it's aligning to the work plane. And then that allows me to move it, but the fall off is modifying it as well, and I can change that fall off over here if I like, so I get a different shape. So let's just clear that out. Reset the work plane. So that's a sequence of steps. Run a tool and then modify it in some way to kind of customize it for a particular task that you want to undertake. But I want to draw your attention to a very important part of the UI. If I go to the Lists tab here, there's a viewport called the pipeline. So let me just run through some of those steps again. So if I make that selection and then run the move tool, you can see that the transform tool becomes visible in the pipeline as a layer, if you like. And then if I modify that with the action center, change that to selection, you can see we now have a selection action center and a selection action axis. So the center defines where the tool handle will be positioned in 3D space, in this case to the average of the selection, and the axis defines the orientation of that tool handle. Again, in this case, average to the normal. And then if I change that, so if I change that to element, you can see that changes. If I add a fall off, the fall off gets added in. If I add snapping, snapping gets added in. And this is how we build tools up inside of Modo. And the pipeline displays the combination of all those elements. Now, interestingly, the majority, or a lot of the tools inside of Modo follow this same pattern, particularly the deformation tools and also the duplication tools. So if I go to the Deform tab and run Element Move, you can see that's a combination of those 4 elements. Soft Drag is a combination of those elements. Actually, snapping's in there as well. And if I go to the Duplicate tab, we have some other different elements for duplication tools. We have clone effectors and path step generators. But what that means is basically a lot of the tools inside of Modo are just presets that have been put together by the developers. So as you can see, the pipeline is the engine room and also the foundation upon which most of Modo is built. As an artist, if you engage with it, then you're really engaging with Modo. It's important to realize that it's much more than just a viewport for looking at things. It's also a place where you can make tools of your own and refine the way they and you work, kind of like sharpening a pencil. So let me give you a few examples of a few tools that I've created that have really helped me. So in this example of a racing car, if you're doing this a lot of this kind of hard surface work, you need tools that really help you to control the flow of a surface and the position of points. Now, Modo has some good tools for this. Element move is very useful. That allows you to grab an element and move it around. The problem with it is the tool handle always aligns to the work plane. And that's good in some situations, but not in others. When you're doing this kind of work, it's really useful to move elements along their normal. That gives you a bit more control in some situations. Now, Modo has a tool for doing that. So if I make a selection and go to the Deform tools, it's a tool called Push. And if I run that and click and drag in the viewport, the element that I've selected moves along the normal, which is great. Problem with it is if I want to now move another polygon, I have to drop the tool, and you can see the tool disappears from the pipeline. I've got to make another selection, then run another tool, and do the same again. What I need to do in this situation is design a tool that's going to help me to do exactly what I want it to do. So let's do that. So I'm going to start by running the push tool, and you can see that comes into the pipeline. If I then click and drag, you can see it's going to push everything. So I now need to modify it. So let's start by defining the element that I'm going to push. So to do that, I can go to the Action Center menu and run an Element Action Center. That comes into the pipeline. That now allows me to select an element, click and drag, but you can see it's still pushing everything. So now I need to define the selection itself. So if I go to a fall off menu, I can now choose an element action center. So now it's only going to let me push the element that I click on. So if I click and drag now, you can see it's just pushing that element. But the beauty of it is I don't have to drop it. I can now go to another element and push that. I can go to a point and push that. I can go to an edge and push that. I don't have to drop the tool all the time and then reselect something. So that's a really useful tool. Now, if I hit spacebar or select another tool, that tool is going to disappear. And I'm going to have to build it again if I need it again. So what I want to do is create a preset of this. Now, I can save it as it is, but there's other modifications I can make to it as well. You can see in the pipeline there are 3 columns. On the left-hand side, we have E, which stands for evaluate. V is visibility, and A is the state of the element of the tool. So A means it's in an automatic state, and M means it's in a manual state. And because I've interacted in the viewport, the push tool is in a manual state. So what I like to do in this situation, because I'm clicking on different elements, the tool handle is kind of irrelevant, and it's just a bit of visual clutter. So what I can do in the pipeline here is come to the visibility column and just decheck V. So now there's no tool handle, and I can just happily click and drag and push these elements around. Now that's a tool I want to use again, so I'm going to save it. So I'm just going to right click in the pipeline, click Save Preset, and I'm going to give it a name, and I'm going to call it Element Push. And I'm going to click Save. So let's clear that tool out of the pipeline. So let's think about another tool. Now another thing that's really nice is to be able to kind of lift edges with a fall off in a really controlled way. Now we can kind of do that already with a tool called Flare, but I want to kind of customize that tool and tweak it for exactly what I want. So the first thing we need to do is make a selection. And then we can start building up the tools. So I'm going to run push. I'm then going to load a fall off. I click in the viewport, you can see that the fall off automatically snaps to that selection. I really like that. And then I'm also going to add in snapping as well. The handle is invisible because I'd already dechecked that on the previous tool, so I'm going to keep that. So let's save that tool. And I'm going to call this Span Push. And click Save. So let's clear that one again. Now there are different ways we can access those tool presets. We can bind them to keys, we can put them on the UI. What I'm going to do is create an actual form to access them. So if we go to the system menu and run the form editor, on the top left we can go create new Pi template, and we'll give this a name, and we'll call it Andy's Tools. Click OK. We'll need done that, it gives you these slots in which you can place different commands. So if I click on the first empty one, and in the command menu I can type $tool.set preset, and then in inverted commas the name of the tool. So element push. Hit return, and then we can give it a label. So I'll call that element push. Let's do the next one. Go to the next empty line. $tool.set preset inverted commas span push. Hit return and then give it a name. Okay, so now to access that pie menu, if I just select the root, right click and then assign to a key, I can then select a key from the keyboard, click OK, and now if I hit that key in the viewport, the pie menu comes up and I've got those two tools there. Okay, so let's run them and see what happens. So if I run element push, you can see that gets loaded into the pipeline now, all in one go, and now I can click and drag on elements. Works perfectly. If I make a selection, I can then run the other tool, span push, click in the viewport. And what's nice about having snapping in with that tool is I can drag the ends of the fall off and drag that onto the ends of the selection. And then if I just click and drag in the viewport, I can push that edge or kind of lift it or sink it in a really controlled way. So these are two examples of how I started to mold Modo's toolset on the fly. Now, it may not be right for you, but it was right for me at that particular time doing the work I was doing, and over the long term made me a more efficient modeler. So another example was when I was involved in some character modeling. Now I needed to pose a character for a still, and I don't know if you've ever tried posing fingers without a rig. It's pretty hard. But using the tool pipeline, I managed to create a tool that really helped me. So in this scene here, I've got this cartoon arm. I'm just going to select the finger. Now, there is a tool in Modo which is quite useful for this kind of thing, and it's called Flex. So I'm just going to run that so we can see it in the pipeline. And this is made up of a number of elements. It's made up of a transform tool. We have a selection fall off, which just gives a softer movement towards the edge of the selection. And we have a selection border action center, which means the tool handle is always positioned at the border of any selection. Now that's great. It allows us to, bend the finger quite nicely in this situation. The problem with it is if I change the selection, you can see because the axis is selection, as I change the selection, the tool handle is moving into positions which aren't very useful for me. So what I need to do is modify this tool slightly to give me a tool that's useful for this one particular task. So let's build a tool up. So we need the rotate tool. So I'll load that into the pipeline. We need a selection border action center. Tool handle will jump there. And we need a selection fall off. And to fix the tool orientation issue, we can go to a different menu, which is under the Action Center menu, but we've got an Axis sub-menu, and we can change the axis to Element. Now this is similar to what we did with the tractor. So what it means now is the tool handle will always be positioned at the selection border, but now I can right-click on any element in the scene, and the tool handle will align to it. So with that finger selected, if I just right-click on this edge at the tip of the finger, I know it's perfectly aligned, so I can rotate that. Okay, let's save that as a preset. And I'm going to call this pose. And let's add that to my form. There we go. We'll type it in. $tool.set preset inverted commas pose. Now we'll give it a label as well. Okay, so let's pose this arm. So I'll make a selection, run my hotkey, select the pose tool, right click on the tip of the finger, rotate the finger, reduce the selection, and rotate it again. Make another selection, run the tool, right click, pose that, and then let's double click on that hand and we'll select up to the elbow, again run my tool, let's align it, and finally at the shoulder. And there we go. A tool that made that whole process a lot quicker, and in the long run on that job saved me a ton of time. Now the great thing for me in all of this, speaking as a fine artist and someone who couldn't code his way out of a paper bag, is I was making tools without having to think about Python or ask someone else to code something for me. I did it myself, thinking creatively about the tools I was constructing whilst I was modeling. And for me, that was really empowering. So over the years, Modo has grown from just being a modeling application to being a renderer, an animation tool, a rigging tool, and a painting and sculpting tool. During this expansion, the development team have always tried to keep each of these elements glued together. It's been a challenge at times, but this drive to keep concepts consistent makes it easier to learn and the process of developing projects within it more fluid. Due to Modo's direct modeling paradigm, there was an inevitable slight disconnect between the process of modeling something and the process of rigging something. But with Modo 10.1, we've now introduced procedural modeling, which starts to bridge that gap. So in case you weren't aware, procedural modeling allows you to non-destructively model, animate modeling operations, and also rig those modeling operations. But what I love about the way it's been implemented is it fits within both the tool pipeline paradigm and also Modo's rigging paradigm. It brings these concepts together in a way that makes sense and allows you to do some really exciting things. So let's take a look. Now what I find interesting about the procedural modeling system in Modo is how it mirrors, to a large degree, how the direct modeling tools work. So if you understand how the pipeline works, you'll get a much better understanding of how the procedural modeling system works. So I've got an example here. So if you want to create a tube inside of Modo with the direct modeling tools, you can do that. So I'm just going to create a profile, in this case just a circle, and then if I go to duplicate, we can use this curve extrude tool, and if I draw a curve in the viewport, we get a tube. And if I go to the pipeline, you can see what it's made up of. So it's made up of this supervector, a path step generator, and also a curve. Okay. The problem with creating a tube like this with the direct modeling tools is that when I'm finished, I've got to drop the tool, and that freezes that geometry in that state. So there's no way for me to go back and change that. If I want to change it, I can go in and use the editing tools to change it if I want. I can change its shape by using these deformation tools, but you can see that's not perfect. It's starting to kind of warp the shape. But if at the end of the day, if I want to create a different tube, I'm probably going to have to make it all over again. But with the procedural modeling, that's a thing of the past. So let's just close that scene. Now the procedural tools can be found on the right-hand side of the UI. So all the direct modeling tools are on the left, procedural on the right. So if you can see, we've got a tab here called procedural. Just click on that. And that splits the viewport. So we have the regular item list at the top, but below it we have what's called the mesh operations list, which is actually the same viewport as the deformer list that was in previous versions of Modo. It's exactly the same thing. So let's go through the same steps of creating a tube, but let's do it procedurally. Now I could start with a regular piece of geometry, but in this case I'm going to start with a piece of procedural geometry. So I'm going to click Add Item, and this preset browser is searchable, so I'm going to type at the top cylinder, and then I'm just going to double click on cylinder to load it in, and we get a cylinder in the viewport. Now all of the properties for that tool can be found in item properties now. Now these are the same properties that you would find with the direct modeling tool, but because they're over here in the item properties panel, you can see that they're animatable channels. So they can be animated and also can be rigged. So let's change these. So I'm just going to flatten that down into a circle. So the next thing we need is a curve to drive the tube. So I'm going to go to a new mesh layer and run the regular curve tool, and let's draw out a curve. And then just so we know it's the curve, let's name that item. Okay, let's go back to the cylinder. So you can see in the mesh op list, we have the base mesh. Above that, we have the cylinder mesh operation, which is creating the cylinder, and that's feeding up to the top, which is the mesh that we see in the viewport. So the whole process of procedural modeling in Modo is we're just layering different mesh operations on top of this, and that's all feeding up into the scene. So the next thing we want to do is do a curve extrude. So let's click Add Item and choose Curve Extrude. That'll ask me for a curve, so I'll select the curve item, click OK, and we now have a tube. Now what's interesting is if I expand Curve Extrude, you can see we have a selection option, but we also have a tool pipe or pipeline option as well. And if I expand that, you can see we have a path generator and we have a path segment generator, and these are exactly the same as the tool pipe elements of the direct modeling tool that I showed you earlier on. So it's the same methodology. So if I want to change how many steps are in that tube, I can just go to steps here, change that to 12, or back up to 30. I can go back to the cylinder. I can change how many sides there are. And the beauty of this is I can also add other things on top. So let's add a thicken. So now we've got a thickened tube. But best of all, I can go back to the curve. And if I just use my direct modeling tools, just element move, I can edit that curve and the procedural tube will update on top of that. There's no way I could have done that in Modo before, but now we can. Just happy days completely. So just take you through some other of these features. So if you select the G button, that selects ghosted. And that means if you go back through the stack, it shows you the item at that position in the stack, and then all the subsequent operations are ghosted on top of that. So if I select cylinder, I just see the cylinder, and it shows me the extrusion, then it shows me the thicken. Now that's a really nice example of using procedural modeling for regular modeling. Now you wouldn't really want to use procedural modeling for all modeling tasks. That would just be silly. There's times when it would be really useful, other times where you just want to use the direct modeling tools. But in the current implementation of the procedural modeling, I think the most powerful aspect of it is how it links into rigging. So let's go over to the Setup tab, because that's where we do our rigging in Modo. And this gives us access to various rigging tools and also the schematic viewport. Now the mesh operations viewport can be found here, which is actually the old mesh deformers viewport, like I said before. Now say I was a motion graphics artist or a UI designer, and I wanted to create a dynamic number that I could reuse on different projects. How would I create that with Modo's procedural modeling system? Well, let me take you through it. So if I, in the mesh operations list, if I add item, we now have a text item. So we have procedural text in Modo now. So I can add some text. I can change the font. And also the justification. just like we could with the direct modeling text tool. But what I want to do here is create a little rig with this. So I'm going to create a locator so I can move this around easily in the scene. Just parent the text to it, and let's call this number mover. And I'm just going to add that into the schematic just by clicking the Add Selected button. And then I'm going to do the same with the text. And if I double click on that yellow diamond on that node, it'll bring in the procedural text node. So what I want to do is drive the actual text that's displayed in the viewport. So because text is now procedural, we have a text channel. So I'm going to select it and I'm going to add that into the schematic. And you can see, because it says ABC, it means it's a string text, so it will only hold string values. So what we need is a channel that will drive that text channel. So with the number mover selected, I'm going to add a user channel. And let's call this number driver. And let's make it a percentage. Use minimum maximum, and let's go from 0 to 100. Click OK, and that brings it into the schematic. So what we've got here is a 0 to 100 value, and we need to use that to drive a string value. So we need to convert that information, and we can do that through a string compose. So we've got a channel modifier, string, then bring in a string compose node. So if we take number driver and put that into integers, and the output, which you can see is a string value, and we'll put that into text. So now we need to write a little expression that will do that conversion. So with the string compose selected, in pattern, I'm going to type $, open bracket, I:1, close bracket. And now we get a 0 in the viewport. Now if I select that number driver channel, as I increase that channel, when it gets to 100, it'll change to 1. How cool is that? So we've now got some dynamic text. So what we can do now is if we multiply this value going into string compose, we can define the range of that number. So if I select that noodle there and go to math, basic math multiply, and then type in, say, 200, and then we run that channel, we're now getting that number increasing from 0 to 200 as we increase that channel from 0 to 100%. How cool is that? And that's something that would be really useful in a lot of different situations. So what I want to do, similarly to how I packaged up a tool preset with the direct modeling tools, what I'm going to do is package this up into something I can use over and over again. And in rigging, we call these assemblies. So first of all, you need to decide what the inputs will be for the assembly. So we've got the driver, but I actually think it would be nice to be able to input or easily input this range value. So I'm going to select number mover, and let's add another user channel and call this range. And this should just be a float. Now we don't want to use a minimum maximum. So we'll hit OK, and then we'll just link range to that multiplier. Okay, so to create the assembly, I'm just going to right click and select everything. Right click again and choose create assembly, and let's call this number. Click OK, and it'll collapse it all down into a single node. What we need to do now is expose those channels to the outside world. So if I double click to go inside that assembly, we can just grab these channels and drop them onto the assembly inputs node. And when we go up, we've now got those two channels there. So to make this reusable, we can just right click and save assembly preset. Click yes. And let's just save it in here. And I think I've already saved one before, but I'll just overwrite it. So I'll replace that, and then let's close the scene. So now if I go to my assemblies and choose a path, and we'll go into that location again, there's the number that I just created. So if I want to use that in any kind of scene that I'm doing, I just drag that into the schematic. There's my number. I can position that somewhere in the scene. I can define a range by just clicking here, let's say 250. And if I select number driver, you can see it's all working. Now what's great about this is I can now art direct this. So if I go to Mesh Ops, select the text, I can change the text. Let's make it Arial black. And I can also modify the text. So let's extrude this. So we would do it in the same, follow the same steps as we would with the direct modeling. So the first thing we do is freeze it. And then we do a polygon extrude. So now we've got three-dimensional text, which we can drive at something. Now, procedural modeling is also really powerful if you not only link it into rigging, but also replicators as well. So here's an example of a problem that can be solved with all three of those. So I want to create a railway track, a procedural railway track. So I have three mesh items in the scene here. I have a curve, which is defining the actual path of the track. I have rails, which is a profile of the rail, and I also have a sleeper, and I think in America they call them ties. In the UK we call them sleepers. So this is the piece of wood that the track sits on. Okay, I've got those three items in the scene. So the first thing I want to do is replicate that sleeper along that curve. So let's add in a replicator. And we want the prototype to be the sleeper. What do we want the point source to be? Well, if I choose the curve, you can see because there's not an even spread of points along that curve, that's not going to work. So what we can do is add a new node. So let me just add all this stuff into the schematic. So I've got my curve, I've got my sleeper. But what I'm also going to add in here, let's do it through here, is a curve particle generator. So now with the replicator, I'm going to add that as the point source. And then if I just hook the curve in, you can see it's what the curve particle generator is doing is it's placing particles along that curve at even spaces. And then if I select the curve particle generator, I can go in and actually define that point count. Obviously 20 isn't enough, so I'm probably going to need about 250. So now we've got 250 sleepers running along that curve. Let's just make replicators visible. Okay. There we go. Okay, so that's the sleepers taken care of. The next thing we want to do is extrude that rail item along that curve as well. And we can do that procedurally. So if I select the rail, let's go to Mesh Ops, and let's do curve extrude. Select the curve, and you can see that rail being extruded along there. It's not quite right at the moment, so what we need to do is invert the polygons, and you can see there aren't enough segments. So if I expand the tool pipe to path segment generator, we can then define the number of segments. So let's go 250, and there we've got a perfect procedural railway track. So at any time I can go back to the curve and just like that tube that I created, I can change the shape of this and the whole thing will update. So I could easily, create different curves to define different track layouts and just drop those into the scene. But what if I wanted to do something a little bit more complicated than this? So let me just bring this stuff in here. Bring in my curve extrude. And all those guys. Okay. So what if I wanted to actually animate this track growing along the curve? Well, because we've got procedural modeling, we can animate an element of the or channel from that procedural item. So curve extrude, actually the path generator for the curve extrude has its end channel. So if I animate that going from 0 to 100, and then just scrub through the scene, you might not be able to see that, so I'll just zoom in. So you can see now that extrusion is animated along that curve. So that was pretty straightforward. What we want to do now is have it so that the sleepers will not be visible before the actual track, before the track's position along that curve. So how would we do that? Well, what we need to do is sample this curve. So I'm going to add a curve probe. And what this does is it samples a curve and gives us various information from that curve which we can use in a rig. So if I take the curve and plug that in, then what we need to do is find the position of the sleeper along that curve at any particular time. So if I select the sleeper, and let's bring in its world position, and we'll plug its world position into the curve probe as well. So the other channel that we need in here is the channel we animated, which is this end channel. So I'm going to add that in as well. Now what we can do with this, what we've got here is say that if the distance along that curve is greater than the animated channel at any particular time, then don't make that sleeper visible. So that's a logic node that we need. So as A is greater than B, we'll bring that in. So we'll bring end into A, the percentage along the curve into B, and then we can define the output for the true value and a false value based on that logic. So if we output 1 if it's true and 2 if it's false. Now 1, if that's plugged into a visibility channel, represents visible, and 2 represents invisible. So if I go back to the sleeper and to channels, got this visible channel, we can add that in. Oops. Where's my visible channel gone? Sleeper. There we go. Okay, we'll take the output from this and plug it into visible. Now, as you can see, nothing's happened in the viewport. And that's because we've got to do some... what we've got to do is decouple that sleeper from the replicator. So what we need is a new layer. I'm going to call this dummy item. And we'll parent the sleeper to that item. And then the replicator, instead of using the sleeper as a prototype, we'll use the dummy item as a prototype and then click include child items. So now you can see it's deleting those items, but you can see it's not in line with the end of the extrusion. If I increase scrub the animation, see it gets to a point there where it kind of jumps along. So the curve probe is obviously sampling the points along that curve, and because they're not evenly spaced, it doesn't know how to delete them in relation to that extrusion. What we can do to solve this is use another procedural modeling node. So it's a very cool one. If we select the curve, go to Mesh Ops, we can add a curve rebuild. Put that in there. And what this does is it puts a certain number of points, a bit like the curve particle generator, puts a certain number of points along that curve, or kind of rebuilds the curve with another curve. And you can define the number of points. So if I increase this to 250, the shape of the curve will be perfect. And now as I scrub, I've got an animated railway track growing across the landscape. So another problem that we can use procedural modeling to solve is the problem of how do you dynamically populate a surface with an object evenly. So there's always the correct number of objects across a surface as that surface changes. The solution in Modo is remarkably simple. If I just create an object, so I'll just create a sphere, and in a new layer I'm going to create a procedural cube. Let's set the height to 0. Okay, so I just got a sphere in one layer and a cube in another. So what I'm going to do first of all is replicate the sphere to the cube. So if I add replicator, set the prototype to mesh 1 and the point source to the cube. So by default, replicator always chooses the points on a surface, but what I'm going to do is change the source mode to use polygons. So now I can hide the sphere, and I'm just getting a single replicator that's sitting on that flattened cube. Okay, so as that cube gets bigger, I need more and more spheres to appear to fill that space. So what I can do is use the procedural segmentation of that cube and use a relationship to drive the segmentation based on the size. So if I add the cube, there we go, there's my cube. So we go to properties. So if I bring in size X, I'll add that, and also segments X. I will add that in as well. So then we create a relationship. So I've got a channel modifiers relationship. And we'll take size X. And we want that to drive the segments. So to define the relationship, I'm just going to use the graph editor. So I'm going to create another key. So when the input is 0, I want the value to be 0. But when the input is 1 meter, which is the size of the sphere, I want the value to be 1. So I want it to be 1 segment. And I want that to grow in a linear fashion based on how much I scale it. So we change the post behavior and the pre behavior to linear. So now, if I select that cube and increase the X channel, when it gets to 2 meters, it'll split, and now I get 2 spheres. I do it again, and again, and again, and so on and so forth. And we could do the same on the Z-axis as well. And there we have an area that we can populate evenly with any particular object. So this is particularly useful if you want to put tiles on the roof of a building, because you want the tiles to remain the same size, but the size of the roof might change. So in this scene, I've got a very simple building. It's got a little locator on the roof, which is where I want to position the actual tiles. And in my assembly preset browser, you can see I've already created an assembly for my roof, so I can use it on different scenes. So I'm just going to drag that into the schematic. Got a little locator in the scene there, so what I need to do is position that on the top of the roof. So I'm going to use Modo's drop actions to do this. So if I set the drop action to match position, select that locator and then just drag it onto the locator on the top of the roof, you can see it jumps into position. And if I change it to match rotation and do the same, it'll align that way. Okay, so what does this do? Well, if I just select the channels in this assembly and then hit C, so if I increase roof X, just like the previous scene that I showed you, I can grow the width of the roof. If I increase roof Z, I can grow it on that axis, and then I can also change the pitch. So I can accommodate any size roof at any angle. So let's just decrease the Z there. And because they're replicators, we can do other things to them as well. So if I increase this random scale, I can change the size of each of them very slightly. And I can also twist them ever so slightly, so it's a bit uneven. That'll just add to the realism. So I just make replicators into bounding boxes just to speed things up, because I've actually gone ahead and created the whole scene here. So if I bring them all in. So as you can see here, all the buildings are slightly different size, but because I used that preset, I know that all the tiles are exactly the same. So if I open up my preview renderer, we can take a look. So in Modo, you now have so many options when it comes to modeling. You can take the fast, direct approach, the procedural approach, the rigging approach, and you can even sculpt. But best of all, you can do all these at the same time if you like, and all within a methodology that's as consistent as possible. No matter what type of person you are or what you're making, it's a process that you define. So unlike that chief designer, I will always care about process, because process is where the magic happens. And in Modo, I found a piece of software that really allows me to engage in that process. It gives me problems to solve, interesting ways of solving them, and a multitude of avenues I can explore to get where I want to go. This is what I love about Modo, and the main reason I've been using it for so long. So a lot of what I've talked about today is pretty fundamental to learning Modo, and it's essential to understand if you're going to get the most out of it. So if you haven't done it already, I would suggest that you visit the Foundry website, and in particular the community forums. They're always a great source of information. Foundry TV, where you can find lots of free videos to watch, and also the training video page, where you can get deeper dives into various aspects of Modo. So thank you so much for taking the time to listen to me. If you're currently using Modo, then keep up the good work. And if you're just thinking about giving it a try, I hope this presentation has given you something to think about. Have a great day.